Welcome to MSM Solutions YouTube channel. In this video, we'll discuss some of the statistical concepts that are used in the lab, starting with the most basic ones that get to be used almost every day in our labs, and moving to others that are not necessarily used every day, but during maybe method validation or when comparing data or comparing different methods, different instruments, and cases like that. So we will try and keep it as basic as possible. Stats can get complicated, but the whole point of this exercise is just try to understand what these terms are, so that when you use them, you can see if something is not right. So if you understand what the calculation is supposed to give you and what the results mean, then it's easy to spot if you have made a mistake or you are drawing data that doesn't make sense. Remember, garbage in is garbage out. So you really need to know what are you inputting into this equation so that you're able to interpret what it gives you back. But if you don't understand what you're calculating, even if the calculation is incorrect, you wouldn't be able to pick that up. So let's get into it. So let's start with average and mean. These are essentially the same thing. Average is the sum of the numbers divided by the total number of values. So if you have a set of numbers, you add them up and then you count how many you have and you divide by that number and you get your average. The mean is a mathematical average of a set of two or more data values. So mean is essentially a fancy way of describing the average. And you would sometimes hear people will talk about average as the arithmetic mean. So mean and average are essentially the same thing. Then we have the median. The median is the middle of the sorted number series. So when you calculate the median, the first thing you need to do is sort them out in ascending orders and then find what is in the middle. So the number that is in the middle will then be the median. So next we have the mode. What is the mode? In statistical terms, the mode refers to the most frequent occurring number found in a set of numbers. So in some series, you'd find that you have more than one number becoming the mode. So if you have one number appearing twice, then and everything else is appearing once, then the mode will be that number that appearing twice. But if you have two numbers that appear twice, then the mode will be those two numbers. But if you have number that is one appearing twice, the other one appearing 3 or 4 times, then the one appearing 3 or 4 times would be the mode. So it will be whichever one is appearing the most frequent, that is the mode. Standard deviation. We use this a lot, but I don't know if we take a minute to actually see how do we actually calculate it. What is standard deviation? Normally we just plug into Excel or any other computing program and we get a number. Standard deviation is a quantity expressing how much the members of a group differ from the mean value of the group. It measures the amount of variation or dispersion of a set of values. So what you will realize is that when your values are quite close to the mean, you will have a low standard deviation, while when you have a high standard deviation, it indicates that the values are spread through quite a wide range. How do you calculate this? So when you calculate it, you don't have to calculate it because we do have programs, but if you're interested in knowing how, this is how you calculate it. The formula is that you take a square root and you sum the difference between the individual numbers and the mean, and you square that. So that's what you'll do. So the first step would be you have a set of data points. You subtract each data point from the mean. You take an absolute number, as you can see. So regardless of whether the individual data points are lower or higher than the mean, you will always get a positive number. You then square all of that. Each difference between the data point and the mean, you square that. You sum all of that. Once you have the sum of these differences between data set and the mean, you then divide that by n being the number of data point, and you get a square root, and that would be your standard deviation. Once we have the standard deviation, the best way to now understand our number is actually to calculate the relative standard deviation. This is a measure of the deviation of a set of numbers disseminated around the mean, and is calculated as the ratio of the standard deviation to the mean for the set of numbers. The higher the deviation, the further the numbers are from the mean. The lower the deviation, the closer the numbers. That's why most of the time you'd find with some analysis there you'd have three numbers and you calculate RSD and you say my RSD must be less than 1%. So how do we calculate RSD? You take your standard deviation and you divide by the mean, and if you want a percentage RSD, you will then multiply that by 100. So normally when you have a very low RSD, percentage RSD, you know that your numbers are very close to each other, while when you have a high one, they are further apart. And this you will already have seen when you compare your standard deviation numbers, and you'll see if this number is high, the dispersion is quite high, and therefore the relative standard deviation will also be high. But the relative standard deviation, the value of it, because you can calculate as a percentage, it gives you a better number to interpret compared to when you're just looking at individual standard deviation. When we speak of standard deviation, you'll also hear people talking about variance. So what is variance? Variance is the average squared deviation from the mean. So what's the difference between standard deviation? Standard deviation is the square root of this number. So there is a relationship between variance and standard deviation. So standard deviation is the square root of the variance. So that is the difference between those two concepts. Okay, similarly, there is a relationship between the coefficient of variation, or sometimes known as the coefficient of variance, and relative standard deviation. So the coefficient of variation is the ratio of standard deviation to the mean. The higher the coefficient of variation, the greater the level of dispersion around the mean, as we have explained with relative standard deviation. In some cases, the coefficient of variation and RSD are essentially the same thing, the same number. However, one needs to note that RSD cannot be negative, while the coefficient of variance can either be positive or negative. So the difference between the two formulas is that when you look at coefficient of variance, you divide by the mean, while for RSD, you have to divide by the absolute value of the mean. So it means that your mean cannot be negative. So if it is, you need to convert that to the absolute value. That's why RSD will never be negative, while coefficient of variation can be negative or positive. These values are essentially used to express precision and repeatability in an essay. So when you're looking at results from your coefficient of variation or RSD, you normally want to interpret the precision of your method. You do percentage RSD and you'll have a value that if my percentage RSD is less than 1%, then I'm happy that my precision is good. Or sometimes with the method, you say my repeatability should be 5% percentage RSD, or you use your coefficient of variance. Another thing I need to highlight as we're talking about these different concepts is that you will sometimes see that we talk about sample and population, and the symbols we use are different depending on if you're speaking of a population or a sample, and even the calculation for some of these concepts are different. A sample is usually what we use for statistics, while the population is the actual parameter. Ideally, we want to calculate for the population. However, it becomes difficult to calculate for the population because it means we need to calculate an infinite number of replicate measurements to get to a population. So now what we then do is, the practical thing is to do a limited number of replicates and have a sample, and then we determine the sample mean, the standard deviation, and any other number that we need. And that is that. But however, when you look at your data, to be able to see that are they talking about population or sample, you then need to have a look at some of the symbols that they use. Sometimes some people might use these symbols interchangeably, but ideally the X with the bar is the sample mean, while the Greek term mu is population mean. With standard deviation, S is usually sample standard deviation, while the Greek term sigma is population standard deviation. So that's also the difference between the symbols in terms of, am I talking about just a small sample or population. We normally want to estimate our population mean from our sample. Ideally, what you want to do is collect as many data points as possible so that your estimate of your population mean is good. Some labs you'd find that they're calculating limits of, let's say, QC values from 10 points. And you ask yourself, is that spread good enough? Is that statistically valid? Is that sample mean a representation of what actually happens, on a day-to-day or shift-to-shift, hour-to-hour population of your results? So ideally, you want to try at least do a minimum of 30 numbers, because 30 is usually seen as the absolute minimum when it comes to some of these statistical calculations. If you can have more numbers, better, but at least do 30 so that when you calculate, you can say that, I'm getting close to my population mean from the sample of 30 points. So you would see that when you look at sample and population, that the calculations are different. So when you look at variance and standard deviation, those calculations will also be different depending on whether you're calculating population or sample. And when you go into Excel as well, Excel will also have, say, a calculation for variance. It will have a variant A or variant SP and things like that. And then you need to know which one do I want to calculate. There's also one that is just an absolute, which doesn't have a symbol next to it, so which you can use that as default. But you need to be aware that there is a difference in how you calculate these depending on if you're working with a whole population or a sample. We have covered most of the basic day-to-day statistical terms that we use and calculations that we use. The next step would now be going into comparative stats. How do we compare two data sets or two numbers? How do we see that there's a significant difference between the two? What calculations do we do, and how do we interpret them? So that will be on the next video as we build on. From now, we understand the basics and some of the basic calculations. Let's now do comparative stats. See you in the next video.